This is StarTalk, Cosmic Queries Edition. For my co-host today, I've got the one, the only, the inimitable. She's so unique in this world, I don't think anyone is related to him. Jordan Klepper. Jordan.
I have no close relatives, very few close friends.
There was an egg somewhere, and you hatched out of it.
I was born onto this earth. Who knows from where, and who knows what will come from me? But here I am.
Yeah, I mean, I first, as for so many people, I was introduced to your work on Comedy Central as a sort of correspondent and running around the country, exploring the depths of irrationality that has befallen us all. And I keep thinking to myself, if he weren't doing this, who would? And no one, right? So I just want to thank you for all of you have done to expose the underbelly of the country.
I feel like I'm like James Cameron diving into the abyss. Okay. But it's not underwater. It's just into the heartland of America.
The heartland of America. So we've got you for Cosmic Queries, and this is a grab bag edition. So, we don't like to admit it, but every now and then there's just like the leftovers from all the leftovers because they didn't fit a category, they didn't fit a theme, and so here they are. It's like the trash bin of questions. Doesn't mean we don't love the questions. It just meant they didn't find a place before today.
Yeah, to be clear, for all of those folks who are out there, you're not second tier. You're just such unique thinkers. You can't be categorized other than the category of trash bin, but still, wear that like a badge of honor, a trashy badge of honor.
Exactly. All right. So you have all the questions, and I haven't seen them yet. Not that we're trying to stump me, but if I don't know the answer, I'll just say I don't know, and we move on. And I love knowing where the people came from, if it happens to be in their signature. And these are all from our Patreon supporters. So Patreons, we changed the rules, so they're the only ones who actually get to ask questions for Cosmic Queries. So those are the rules.
And to be clear, I know it's not the goal, but I do hope they stump you, just because
Sure.
You're cocky. Neil, you're cocky, and it's important to knock you down a peg. For me, it makes me feel better about myself, so I'm really rooting against you on this one, Neil.
Just before you begin, there was because people like trying to stump you. They won't even try to not stump you if they could. They'll put in extra energy to stump. So I once tweeted that I once tweeted that a plane whose engine fails is a glider. A helicopter whose engine fails is a brick. Okay. So I thought it's pretty clear what I'm talking about there. But no, okay? So apparently helicopter experts jumped in and said, no, the engine can fail, but the propellers will still turn, okay? And then you have something called auto rotation where you can kind of guide your fall from the sky. Like the little, the seeds that can, that fall off the tree that have little propeller blades. They don't just fall straight to the ground. They have a controlled descent. And so no one volunteered to say, maybe Neil meant there's no upward lift at all, okay? An engine failure along with the propeller failure, right? No one volunteered that possibility as to what I might have been intending. And so they all just said, we're going to prove Neil wrong. He's wrong. He's so wrong. Okay. This is how it is. What's the first one you have?
Let's jump into Sandra. Sandra Pagliani has a question. Mm-hmm. She says, first of all, woohoo, what a thrill to be on Patreon. Thank you, Sandra. She says, I've been diving into multiple books on the multiverse, and I'm still struggling with the string theory concept. Could you please explain it in a simple way or write a string theory book for dummies so I finally get it? Thank you.
Well, so a great book on this, which was a big bestseller, was from my friend and colleague Brian Greene. He wrote a book called The Elegant Universe. And there's a lot of other stuff in there, but he's a string theorist. And so string theory deeply infuses his writings because that's the side of the fence he's on as he comes to the topic. So what I can do is tell you that we have quantum physics, all right? That's the theory of the small. So that gives us an understanding of molecules and atoms and particles. And then we have Einstein's general theory of relativity, which explains the entire universe, what gravity is doing to shape the universe. And out of that, we get the Big Bang and black holes and all manner of other things. But it turns out, if you take Einstein's general theory of relativity and apply it all the way down to the center of a black hole, where is what we call a singularity, it blows up. I mean, not literally, it mathematically blows up. Do you remember when you took math in like high school? You weren't allowed to divide by zero, right?
Mm-hmm.
Okay, it's kind of like that.
The man was holding me down. That's how I always saw it.
That's how you felt about it, yeah?
That's how I felt.
You wanted to do it, that just somebody was in your way, right?
You don't tell me what to do, Mr. Forrester.
So we know general theory of relativity has limits, all right? It applies in all these large-scale places, but when you get down to these tiny areas, it doesn't. Now, so here's the problem. At the Big Bang, because general relativity takes us like from the Big Bang onward, but right at the point of the Big Bang when the universe was really small, wait a minute. If the universe was once small, then maybe quantum physics applies to the entire universe in those few moments. So you have a shotgun marriage of these two highly successful theories of the universe, but we don't know how to do that. String theorists have come in and said, we have an umbrella that will enclose them both and put them under one coherent understanding of how the universe works. And we get the singularities out of it, we get quantum physics, and we get general relativity. So that's my sort of overview of what string theorists are trying to accomplish here. But they haven't really yet. And there's been a lot of them working for decades. And I've gone up to them and I say, how come you're not there yet? I've been waiting around. They've been at this basically since the early 80s. And there's like dozens of them, right? Maybe even scores of them. I said, how come you haven't done it? He said, well, it's hard. So then I said to Brian Greene, to his face, I said, could it be that you are all just too stupid? Why is it that it's hard and you're not smart enough, right? It's not that you're not smart enough. What's going on there? Of course, no cosmologist, theorist, physicist is going to say, I'm stupid. They'll say the problem is hard. I take a different sort of view. I think maybe there's yet another place to explore for this umbrella, and maybe it's not string theory. I don't know. But that's where we are now. The two are still not married.
Well, I mean, marriage equality, even in the galaxy in and of itself, is a process. I think American political system says it's not that it can't happen; it happens slower than we want it to.
Yeah, that's what it is. It's happening slower than we really want.
Exactly.
Yes. Yeah.
Exactly. This is from Scott W. Peterson. In this month's National Geographic, there's an article about our investigation of small solar system objects. In it, there's a little discussion about the formation of the solar system. The theory is that Jupiter formed closer to the sun, and when it moved outward, it affected the orbits of outer, icier objects, thus hurling them toward Earth. This bombardment was where we got water from. Why couldn't it have been the opposite? The Earth formed out there where there is more ice, then was catapulted inward to a point where the ice becomes liquid.
Oh, very nice question. Man, I love it when people read and think, and this is good.
This is a thoughtful audience. And they're magazine subscribers.
And that means they read.
They read. Print is not dead. It's alive. It's coming to this man's house. I bet this guy, I got to believe, Scott, I believe, has that beautiful wall of yellow National Geographic.
Oh, yeah, everybody does. Yeah, the yellow rectangle. Yeah.
I love the wall.
Yeah. So, okay. So here's what happened. We had our own solar system. Before 1995, we were the only known solar system. And so we presumed that we'd be representative of other solar systems. Because we got to start somewhere. Let's assume that. We start discovering other planets beginning in 1995. And the method favored the discovery of big planets, even if there were little ones there waiting to be seen. And what we found were that there were Jupiter-sized planets orbiting really close to their host star. And we said, who ordered that? Jupiters belong out, way out where our Jupiter is. How did that happen? And we kept looking, and there they were, and they kept showing up, and they kept showing up. And so we had to ask, what's going on? What is normal? I guess is how you hit this. What is normal? And we went back to the formation drawing board, and we noticed that in a solar system, you could start out with many times more planets than you actually end up with, because some planets' orbits are unstable. And what we mean by that is, if you come too close to a planet, it can slingshot you out. You can exit the star system. But by doing so, it has consequences in the solar system itself. So for every planet that gets flung out, the remaining planets readjust in their position. And it's a whole migrational thing going on in the solar system. It's called planet migration. And planets can move in, planets can move out. It depends on the circumstances of what's going on here. So if you have a Jupiter that's far out, we can imagine that the exchanges of energies and the capturing of other objects can force that kind of readjustment to give you the spread of what we actually see in our catalogs of star systems. So that's what's going on there. And in fact, I get to do this because this is StarTalk. The StarTalk book, and our boy reads, right? We have a reader in the house.
Yeah.
Our recent book, StarTalk Cosmic Queries, there's a whole section on the formation of star systems and this migratory process. So I invite you to check out that book. It's a fun book, and it's published by National Geographic. Mic drop.
What? Look at this. This is why, Scott. You come well read. You're gonna get a well read response. That's what you're gonna get. All woven together.
It's all tight. Tight answer.
Yep. Mm-hmm. Tight, and it's got a sponsorship attached to it. I mean, this is how you make podcasts.
And it's a beautiful book, and it was one of our engineers and editors and producers, Lindsay Walker, was a major a contributor to that, just making it StarTalkifying the content to make sure that any StarTalk fan feels like they are at home in that book. And so we got this.
I love it. I admit I'm embarrassed. I've never heard of planetary migration before.
Yeah, well, so you need a life. You got to get out more, Jordan.
That's what I told you. Without any family or friends, just as this egg who was birthed into the world, I'm still grasping at straws.
Yes, there you go.
Paul Love, he's got a question for us. Mm-hmm. He says, when we say that the universe is expanding, are we really talking about just the matter in the universe, or are we talking about space-time itself? For example, during the rapid expansion of the Big Bang, was it just all the matter in the universe expanding into pre-existing space?
Ooh, okay, I can answer that, but only after we take a commercial break.
Well done. Cliffhangers.
You see what I did there? Yeah.
It's classic.
I'm getting better and better at that. Yeah,
this was really good. Make them wait.
When we come back, we're going to find out what the hell is the universe expanding into, and what does it mean even for it to be expanding on StarTalk Cosmic Queries. We're back, Cosmic Queries, StarTalk. Got with me is my guest co-host, Jordan Klepper. Jordan, love you, man.
Right back at you, Neil.
Love you, all your work. And you still got the gig with Comedy Central, right? And the Daily Show.
I'm still contributing to the good old Daily Show right now. So I launch out into the world every few weeks and see what the world's talking about.
And do you pitch stories to them, or do they request of you?
I do. It's a little bit of both. We basically, I have a small little team that I tend to go out to some of these rallies and events with, and we kind of watch the news. And when a rally shows up or there's a protest, we went to a mask mandate protest a few weeks ago. There's a couple events coming up. We sort of look at where the conversation's going, and if there's an event, we try to get there and talk to people. So
and the more irrational the conversation, the more likely you will be there to report.
It is, exactly. If you're like, man, I bet some people have some irrational points of view and are pretty angry about it, a chance I'm staying at a hotel.
All right. So keep them coming. We got questions from our Patreon members.
Yeah, so this is Paul Love's question. He wants to know, when we say that the universe is expanding, are we talking about just the matter in the universe, or are we talking about space-time?
Yeah, so this is what we learned from general theory of relativity, Einstein, that space, which we think of as this empty thing, and of course things can move through space. Earth is moving in orbit around the sun through space. The sun is orbiting the center of the galaxy. It's moving through space. And there's some galactic motion where they're moving through space. However, underneath all of that is the fabric of the space-time continuum. That is what's expanding when we speak of the expanding universe. And so, no, the expanding universe, and we see galaxies hurtling away from each other, they are being carried along in the fabric of the space-time continuum. And by the way, that means in the early universe, there's no rule against that fabric stretching, really, faster than the speed of light itself. The speed of light speed limit is a restriction on how fast you can move through space, not how fast space itself can expand. So the entire early universe, it is booking. It is going way faster than the speed of light. Not a problem. Not a problem there.
When I'm visualizing this and using even the term fabric, should I be thinking of it in that sense?
Yes.
Of something that is literally being pulled?
Yeah, I think another way to fabric is a little more poetic rather than just rubber sheet. But the rubber sheet.
Yeah, rubber sheet makes me think of sixth grade and the difficulties I had at night after I had a big cola before going to bed.
Oh, is that right? Oh, gotcha. So is this the first you admit this of your childhood?
I think it's coming out. I want to be open with everyone. We clearly we have readers here. We have readers. I want to be honest with readers. Okay. Normally, I'm talking to people who haven't read a book. I'm talking to people who've read books. Here's the deal. Sometimes people pee in the middle of the night, and it's okay. As long as you have the fabric of the universe underneath.
That's right.
Which I gotta say, that's some good branding right there. StarTalk branded fabric of the universe rubber sheets
for bedwetters. Yeah, there you go. So you have a rubber sheet, and it distorts when you sort of press it, as a mass would do to it, pressing down. And if you moved along that rubber sheet, you might sort of fall in towards that depression where the mass is. And that's kind of what things do when they're moving through the pre-existing universe. The point is, if you take that rubber sheet and draw galaxies on it, and then just take it and stretch it, then all the galaxies are moving away from one another as part of the embedded rubber sheet that we're talking about. Now, here's the part that's harder for our limited ape brains to process. This stretching rubber sheet with these dimples in it is happening in 3 dimensions. So it's a 3-dimensional stretching rubber sheet with galaxies embedded in it. And since time is a factor here, there's a 4th dimension in it as well. Right. So that's why, by the way, so let's take a balloon. They didn't ask this, but it rounds it out. Take a balloon and draw galaxies on it, and then you inflate the balloon. Okay? So the balloon gets bigger and bigger and bigger, and all the galaxies are getting farther and farther apart from each other. Then you say, point to where the universe began. Every place you point on the surface of the balloon, no place you point on the surface of the balloon gets you to the beginning. Because the beginning is back through time. You got to go through the fabric, go back through time to when all the balloon was in the same place at the same time. So basically, everywhere is the beginning of the universe. 14 billion years ago.
Well,
clear as mud.
I was gonna, it was the rubber bed sheet. I was getting somewhere. My brain was really starting to make sense of it. The balloon, I like that metaphor. But now moving through space and time, I'm seeing an exploded balloon. And
so when I came up in the ranks, educators were attempting to go 1 dimension higher than the rubber sheet, and they talk about raisins in a raisin cake. In an oven.
Raisins in a raisin cake. Oh, as that it can. Okay.
So as the cake expands, when you bake it, the distance between the raisins are increasing. The problem there is the raisin cake has an edge to it. Okay? And whereas the surface of the balloon has no edge.
I mean, also one of the other problems is raisin cakes have fallen out of favor. You're not gonna find yourself with a raisin cake. Like until you can connect it to a cronut, you're gonna have a hard time for the younger generation.
Nobody makes raisin cakes anymore. It's just not a thing.
It's because you have to understand the 4th dimension and what time means to a raisin cake. And people are like, Kids these days are too dumb to eat raisin cake. This is from
that's
Tyler.
why it fell out of favor. I didn't
That's what it is.
Okay.
Kids aren't smart enough to eat them. This is from Tyler Pitts. Hey, new patron here. Excited to join the family. My question is about dark matter. We have no clue what it is, but what are your speculations on what it could be? And what is the possibility of us interacting with it anytime soon? Could it be that dark matter is the material/matter of the void that our universe is expanding into, outside the observable universe? Just a thing that's been on my mind. Thank you guys, and all the love from Michigan. That's my home state, so a lot of love.
Is that right? Cool.
That's right.
Michigan in the house.
Michigan in the house.
What's your hometown?
Kalamazoo, Michigan, right there. Okay. Home of Derek Jeter and Jordan Klepper. And if you go there, people really know one of those names if you go there.
All right. So we're talking about
dark matter.
Dark matter. Okay.
And what it really could be.
There's what I want it to be, but there's what I really think it probably is. Okay. All right. So I'll tell you what it probably is. It's probably a class of particles yet to be discovered that has a very low probability of interacting with our class of particles. Electrons, protons, neutrons, and even our light. Okay, light is photons are part of our particle family. And so we have our particle family, and there may be a whole other particle family that just simply doesn't interact. But if it has mass, it will have gravity, and we see the gravity of the dark matter. That's why we're calling it dark matter. Okay, it's matter and it's gravity. 85% of the universe's gravity comes from it. But it's coexisting with us by not interacting. And that sounds kind of weird, doesn't it?
That sounds like Thanksgiving. You're describing Thanksgiving. It's families coexisting but not interacting.
There's no real connection there.
There's no connection, and the chances of them connecting are pretty low. Yeah, American Thanksgiving. Got it. Okay.
We need who's the guy who painted Thanksgiving and all those other American images?
Norman Rockwell.
Norman Rockwell. So
yes.
We need an updated Thanksgiving painting where people are screaming at each other.
Yeah, I think it's a triptych of three of people as far away as they can be, and carnage in the middle.
So what was I talking about now?
So you're talking about that's how you imagine dark matter. That's how you hope dark matter exists, or that's how you think dark matter exists.
So it's not a stretch to imagine two things not interacting. All right. For example, why do you have windows in your home? The windows are transparent to visible light. Okay? Now, it turns out the light does interact with the window. It interacts with particles and keeps moving through coherently. But what I'm saying is you have windows that are transparent to visible light. They're not transparent to infrared. And how do I know that? Because you could take a candle or a match and light it on one side of the window and bring your hand right up to the other side of the window and you will not feel the heat. Whereas you can see the match. So the visible light comes through the window, the infrared doesn't. We live in a world of non-interacting phenomenon, all right? And we exploit that fact, all right? You have probably a smartphone on your hip or on your desk right now, and if someone's calling you, it will ring. Where did that signal come from? It came through your walls, okay? You could be in a windowless bathroom and your phone will ring because microwaves pass through all of that. Not interacting until it hits your phone, then it interacts. So we have built our lives to interact with and not interact with certain forms of energy. And that's all the same family of energy. So let me keep going. There's a particle called the neutrino. Once again, it's part of our family. Neutrino hardly interact with anything. Oh my gosh. You need, in order to detect a neutrino, you need like a column of lead light years long, and then send the neutrino through that, and maybe it'll stop somewhere in the lead cylinder. That's our own family of particles. So we are imagining other families of particles out there that interact with us less than even the stuff that we don't interact with as part of our own family. That's the over-under on what dark matter is, and we've got top people searching for those particles right now. Because if we're hoping that it's not just that they never interact, they just rarely interact, so that maybe if you have an experiment big enough and the experiment lasts long enough, they'll have one encounter where the dark matter interacts with our matter, and then we would have experimental evidence of its existence.
We're working on that?
We got top people working on that. Now, my favorite explanation is that there's a parallel universe that has more gravity than we do, and it's spilling into our universe, affecting the movement of our objects. And we're trying to, it's like, the elephant. What am I touching here? What is it? We're touching the dark matter. Ooh, it must be something. I don't know. But it's regular matter and regular gravity spilling out of an adjacent universe. That's what I want it to be, because that's the simplest explanation.
Yeah, and I mean, it's the most fun. And definitely that if that's a world that is beamed into my Netflix, I'm watching season 2, season 3. We're jumping back.
You're sticking with that one.
You're sticking with that one.
And by the way, I'm not just making this up. In a parallel universe, if you look at the properties of these phenomena, light cannot escape the confines of a universe, but the force of gravity can, it turns out. And I didn't take enough quantum field theory or field theory in general to fully understand why that's so, but I've been told this by people who do know this and who are experts in field theory. They tell me that the properties of gravity allow it to leak out of your universe. Really? And even though the light can't. So you're not going to be able to see the other universe, but you might be able to feel it.
I'm imagining like a muffin top, like it's spilling it out over.
Oh, yeah. Oh, I like that. All right. Give me another one. What do you have?
This is from Scott W. Peterson.
Mm-hmm.
Why have car antennas gotten so much smaller over the years? The wavelengths of the radio frequency hasn't changed.
Oh, I love, man, we got good people out there.
This is not a trash group.
Oh, man.
So far from it. This is a well-read, outside-the-box thinkers.
Oh, okay. Okay, so here we go. First of all, you don't see car antennas anymore. And even when they first started going away, it's because they put the wires in the window or in the body of the car. So I remember my first car that had no antenna, there was a pair of wires that were embedded in the windshield glass that came up the middle and then parted out left and right. And those were the radio antennas back when we were receiving radio signals. Okay. And so the AM radio, it's a long wavelength, and generally you want an antenna approximately the length of the wavelength. Okay. Today, most of our communication is microwaves. Okay. When you get satellite radio, that's all microwaves, all of that. Microwave waves are much smaller than radio waves. That's why they were called microwaves to begin with. All right. A microwave is about a centimeter long. And so that's how you're doing your communicating. That's all you need. That's why walkie-talkies never had big antennas like the old cars or even the who else had big antennas back then?
I guess I never knew the antennas were reflective of the actual size of the wave.
Correct. You want the antenna to kind of match, all right? And if it doesn't match it perfectly, that's okay. You'll get some percent of the radio signal getting absorbed. So we're cool with that. And and nowadays, of course, everything's coming over the internet or in other ways, but microwave is the primary way that these things are obtained. Now, there was a trick that they performed, and you might see this in some old-timey cars, but not so as old as to have the antenna. If you take an antenna that's long and just coil it, then the wave still feels the length of the wire of your antenna, even though the antenna is coiled. And so a coiled antenna gets some of the signal that if it were uncoiled that it would get. And that was a way to not have stuff just sticking out as you drove down the street. And so, yeah, that we transitioned through that to then just change the damn wavelengths.
It's like, it'd just be easier. People are tripping over these cords. I remember having one that at my little my little radio player by my bed when I was a kid that it just had a cord that went all the way down, and it was a big mess, to be quite honest.
Yeah. Okay. Yeah. So that was a great question. Yeah.
Yeah. This is from Fernando Gomes. Greetings from Brazil. And yes, Neil, I read your letter to my country.
Oh, he did. Yes. I wrote a letter to Brazil a few months ago, just not to people, to the country.
The country of Brazil. And
it was me
sounds like they got it.
to the country. That's what.
What was the letter to the country of Brazil?
Okay. So it was, I remember one of my books, Letters from an Astrophysicist, was being translated into Portuguese in Brazil. And they said, do you mind writing a letter to the Portuguese people just to welcome them to this book, to this translated book? And I thought about it. I said, no, I don't want to write it to people because people are so divisive and things. Let me write it to something that's not going to complain, something that can't say anything. So I said, I wrote a letter to Brazil. And that letter, it leads off the Brazilian translation of it. And it's a celebration of all that we in America know, in the United States, know of Brazil and things that maybe they can and be more proud of. Brazil had early pioneers in aviation, for example. The very first South American astronaut was Brazilian, okay, for example. So they have most airplanes that you ride between medium-sized cities in the United States are designed and built in Brazil.
Really?
Embraer is a Brazilian aerospace company. And so we tend to think of Brazil as people with not much clothes on the beach, and we think of coffee and maybe soccer, right? And so I, as a scientist, wanted to make sure that all the rest of what Brazil has been and represents and can still represent doesn't get forgotten. And so it's a celebration of a country, all it has been and all it can be.
Look at that. So if I want you to write me a lovely letter like that, do I have to convince you to write it to like the borough of Brooklyn instead?
Is that where you live?
That's what I was going to say. Yeah, you come on. I'm dying for a lovely, thoughtful letter from Neil, but I guess he has to envision me as a city-state or at least a borough. So, well, I want to get to Fernando's question, Neil, but let's take a break first. What do you think?
Oh, okay, sure. So we'll be right back. StarTalk Cosmic Queries. So Jordan, we're back. We left off. We were on the beaches of Brazil last I checked.
It was nice. The weather was nice. It was a good vibe.
Did Mr. Gomes, what was his question? Did I answer his question?
Fernando wanted to thank you, but he also did have one question.
Oh, he did? Okay, Fernando.
I'm going to throw it out here. He wondered, is it possible for the dark energy phenomenon, aka space-time expansion, to be an emergent property of matter itself, only manifesting in bigger scales? Like little ants don't look very complex themselves, though they can show interesting behaviors when you observe the colony as a whole.
Once again, a highly literate question. It's a scientifically literate question. I love it. So let me just unpack something there. He mentioned emergence. Emergence is a relatively recent exploration going on in the field of biology. All right. I think we've always known about it, but we hadn't really thought as deeply about it as we have in recent decades. So emergence is, you can look at a bird, snatch a pigeon off the fountain, right?
Which we don't recommend. StarTalk does not recommend. This is a theoretical conversation.
Thank you.
I got lawyers in my ear, Neil.
So you grab a pigeon and then study it all you can and all you want, right on down to its molecular makeup, okay? So it's got a brain, a beak, eyes, it can lay eggs if it's a girl pigeon instead of a boy pigeon. It's got feathers. It can fly. You figure all this out. We don't yet know what's going on in the pigeon for it to know that there are occasions where a bunch of them take flight simultaneously and then flock together as they fly. So the flocking of birds is emergent, because it's something you can't deduce from studying a single bird and knowing practically everything. Maybe there's something in the brain that we haven't gotten to yet the neuroscience of pigeons, that's probably lower on the list than the neuroscience of humans. Maybe we'll get there eventually. But emergent behavior are things that the sum of the parts themselves are not concerned with. Don't concern themselves with it, but the collection of parts together have a property that has emerged. And consciousness, human consciousness, is considered one of those things. Could it be that once you have a sufficiently complex brain, does consciousness just emerge? And so, yeah, these are very deep. So is dark energy an emergent feature of the universe and gravity and space? I don't know. It's kind of cool to think that, right? But it would be weird to say matter, which attracts itself, has an emergent feature that repels itself. That's just kind of, I don't know how to walk into a room and say that.
Confidently.
So, no, but it's an interesting thought, and I love the concept of emergence, and it shows up in all kinds of ways and places among us.
Tangential question. You talk about pigeons. What is it about pigeons? I know there's stories of Tesla befriending a pigeon, and that being one of the
Tesla the car or Tesla the human being?
The human being, Nikolai. And the cars. I don't know. I'm not rich enough to know what the cars make friends with. But I know the human being was buddy with the pigeon. For my,
he spent his later years in New York City in a hotel in Midtown, and I heard rumors that through the open window, because pigeons in the cities go together, right?
Yeah.
And actually, I think they're technically called rock doves. And they thrive in canyons with steep sides that have rocks. And that's precisely what modern cities are that have tall buildings. So pigeons are right at home with our civilization. And so if you feed them in a windowsill, they'll come back. I don't have all the story there about Tesla's later years, but I just know the physics that he contributed to in his earlier years.
I love thinking of them as rock doves. That's
yeah.
I mean, flying rats I've heard before. Feels like a pejorative. They've never done anything to me, so I'm going to stick with rock doves. I got a question from David Peterson here. He wants to know, Neil, I was hoping you might be able to offer your opinion on what you think we would see if we traveled at the speed of light. I've thought about this quite a bit. I was wondering mostly if there would be a redshift in what would be seen.
Yeah, so since you can't actually travel the speed of light, let's do the next best thing and travel 99.99999% the speed of light, okay? And, oh, by the way, there's an author, a brilliant physicist and popularizer named George Gamow, Gamow, the W pronounced as a V, George Gamow. And he wrote mid-century last year. One of my favorite books ever was written by him. It's called 1, 2, 3, Infinity. It's still on my shelf. Read it in middle school, and it's a brilliant exposition of science and math and really cool topics. So in there, he, not in that book, but he wrote a series of books called Mr. Tompkins, the Mr. Tompkins series. And this is, Mr. Tompkins, I think that the root name of the series is Mr. Tompkins in Wonderland. But is it Wonderland? No, that's Alice in Wonderland. I'm getting my fictional worlds mixed up. But it's definitely Mr. Tompkins. And he goes into worlds where the constants of the laws of physics are different. And one of the stories is the speed of light is 60 miles an hour or like 100 miles, something where you're in a car and you can approach the speed of light just as a regular Joe doing so. And when you do that, he then describes what you see and how things get distorted. And so I highly recommend the whole Mr. Tompkins series because it brings exotic phenomenon of physics into your everyday life experience.
Now,
so if you go very fast near the speed of light, the light sources in front of you become basically blue shifted. They have higher energy than you would otherwise measure them to have. And if you look behind you, everything has lower energy. So there's this focusing in front of you where everything in front of you becomes brighter and brighter and brighter. And if you follow the light trajectories, it's called ray tracing. You follow what the light does, it actually narrows your field of view ahead of you. So in Star Wars, they make the jump to hyperspace, all right? And that's their word for hitting light speed. And they did the visual on that first. And it's not perfectly accurate, but you get a sense of this focusing of light energy that's sitting in front of you. That is what happens as you speed up and go close to the speed of light. And in Star Trek, of course, they call it warp speed. That would be the speed of light for them. And then when they hit the Star Trek movie, which came after Star Wars, they did that light effect as well. So now that's just standard operating procedure for the visual effects people.
Yeah, it's a number 4, I think is what it is.
So it's fun, and I recommend that series. Check it out, and you'll learn more about other things that can be different when you change the constants of nature.
I got a question here from Tamara Michael. Do you think we will ever be able to develop dark matter vision goggles that will work in outer space similar to night vision goggles on Earth?
I love it.
Yeah.
I love it. So if we figure out that dark matter is a certain kind of particle and we figure out how to detect it, that's the thing. Something can be there, but what good is it if you can't then capture it and then do something with it? All right? I mean, think about it. Before we discovered radio waves, we were bombarded by radio waves by the sun. We had no way to even know that was happening because they passed right through us. Until we figured out how to make a radio wave detector, now we can aim it where we want, detect it, and then process it. And then we fully exploited that and turned it into music and TV and everything else. So if once we figure out what dark matter is and how to detect it, I don't see why we can't flip up some dark matter goggles and then look at the grandeur of dark matter in the universe. That would be beautiful.
Tamara has actually one more additional question here that is fascinating. She wants to know, why do we think we know anything about the outer galaxy if we can only see back in time as we look further away? Couldn't everything we see and or think we know be drastically different by now? If there is life on...
Man, these are good questions.
These are good. If there's life on other distant planets, would we ever really know unless we actually go there?
Okay, so this is great. I'm loving it. I'm tickled by it. These are my people. My StarTalk people.
These trash people are good people. You know?
Oh, the trash bin, the question trash bin.
The trash bin folks. What a great crow.
They got the smartest questions of them all. Okay. So it's a smart trash bin, that's all. Okay.
It's a smart trash bin, yep.
So first, it's a brilliant question. And we ask that of ourselves in the professional scientific community every now and then. And here's what gives us the confidence. Because it is true, the only thing of the universe that we know is happening now is what's going on right under our noses here on Earth. When we look to the moon, whatever's going on in the moon happened 1.5 seconds ago. Okay? We look at the sun, that happened 8 minutes and 20 seconds ago. If some giant plucked the sun out of the solar system in this instant, we would still feel the sun, we could still see the sun, we'd still be orbiting the sun, and we would do so for another 8 minutes and 20 seconds. And as you go farther out, these objects are coming to us from farther and farther in our past. So watch what we do. We look in our laboratories, that's happening now, and we measure the speed of light, the values of the quantum constants, like Planck's constant thing. We measure what elements do when they're heated, when they make spectra. We get all of these physical properties, and we have books with these properties in them. Then we look out a little ways, okay? How about to the outer solar system? How about the planet Uranus? How does its orbit? Oh, its orbit is not following Newton's laws. Oh my gosh. Okay, we found the limit. There's a limit in space. Forget time. There's a limit in space where the law doesn't apply. Oh, wait a minute. Uranus is being tugged on by Neptune. Neptune hadn't been discovered yet. So we discovered Neptune. Oh my gosh. So now that we factor that in, it is following Newton's laws. Oh, wait a minute. So there are two stars out there farther away than the planets, and they're orbiting each other. Bam! They're following Newton's laws. okay, this is cool. Let's look farther out in the galaxy. Let's look to other galaxies. Oh my gosh, the spectrum made by carbon and oxygen and nitrogen matches exactly the spectrum we have for it here on Earth. Oh my gosh. So as we inched our way out, we tested whether the phenomenon we're observing matches the phenomenon that we've established with properties that we've established here on Earth in the here and the now. And in fact, they do. And it applies not only across space, but through the depths of time to the beginning of the cosmos. And that's why science works at all. If it just changed everywhere willy-nilly, then the science would only be good like here on Earth and nowhere else. But we got this one. And it was not a given. People say, oh, science has faith that it would. No, we have measurements that tell us this. And that's why we proceed with confidence going forward.
Boom.
Is that a mic drop?
Boom. What I'm impressed, the people who live on the sun, which we'll get into a next episode, are going to hear.
They live on the dark side of the sun.
They live on the dark side of the sun.
That's cooler there, yeah.
It's going to be in 8 minutes and 40 seconds. They're going to have some knowledge drop on them. That's going to blow them away.
I hadn't thought about that.
They don't even know what's coming. They don't know what's coming.
So, Jordan, I think we ran out of time on this one, but thanks for coming in for this. And we're going to continue to watch you on Comedy Central. And I get to say, every time you have a segment, I say, I know that guy. And he knows my name. That's how I feel.
I still have the deGrasse part. I have a hard time pronouncing. Is it deGrasse? But other than that, you're totally correct. Yes. Well, I love being on here, Neil.
I'm Neil deGrasse Tyson, your personal astrophysicist. As always, bidding you to keep looking up.